Hello. Today we're going to go over an Android client that connects to a backend running in Windows Azure websites. This is part 3 in a video series going over connecting mobile clients to backends hosted by Windows Azure websites. In part 1, we created a Windows Azure website, pulled down PHP code from GitHub, configured that site, and pushed it out to Windows Azure websites. In part 2, we went over an iOS client that connected to Windows Azure websites. In this session today, we'll go over a similar client in Android. If you prefer a written down walkthrough of this tutorial, you can go to the bit.ly link shown here. As a reminder, this site functions as a URL shortener. Our mobile app will be able to make use of two different web services provided by the PHP site, pulling a list of shortened URLs and adding new shortened URLs. Really quickly, let's look again at the website as it's currently deployed. When you first go to the website, it just gives you a little description of what it does. Then we can click on this link here and view all of the already shortened URLs. As you can see here, we've already shortened a few of these, and we have the full URLs on the right side. Let's go ahead and take a look pulling down the code from GitHub and opening it in Eclipse. The source code for this Android application can be found by going to the Windows Azure's -samples organization, and then looking for the URL shortener -android-client repository. Let's go ahead and clone this repository locally. Now that the source code is here locally, let's go ahead and import the project into Eclipse. Now that our application is imported, we just need to allow it to compile. Now that our app is compiled, let's go ahead and start it and run it using the AVD or Android virtual device that I already have running. So, as you can see, there's an error fetching the URL data. We should try again later. The reason that this is happening is that we haven't actually configured our application to go against the website. Right now it's using a URL that does not exist. Let's do that next, and then we'll rerun our application. We're going to go ahead and return to the browser for a second and go back to our website. As you can see here, URL shortener test is the subdomain of our site, and the distinct thing that makes it our specific site as opposed to someone else's site running on Azure websites. Let's go ahead and copy that and go back to our code. If we expand the MISC package, we can see there's a constants.java class. Let's open that up. So here we have three different URLs, all of them with this your subdomain in them. We just need to replace that with what we just copied from our website. Now when our application runs, it's going to know to go against our website, and it should run correctly. I'm going to go ahead and save those changes, and we'll rerun our application. Okay, so now we see that after a few seconds of running, it's pulled up all of the currently shortened URLs. We can tap on one of these, and we're taken to the details of that URL. So as we can see here, the slug is MS, the full URL is Microsoft.com, and the shorter URL, well, we kind of have to scroll over to see what it really is, but it's basically our website /MS at the end. Let's go ahead and go to that URL now. So the application is opening that site in the Android browser. As you can see, it's going to show us the full URL of the site that we're going to. Now the backend website is configured so that it won't actually redirect you to the full site, the full URL site. Instead, it just kind of prints out what it is. This is just for debug purposes. We could very easily uncomment one line and comment another line, and instead of just showing or echoing out the full URL, we'd actually go to the website. Let's return to our application and go back. Let's next look at adding a new URL. Next, we'll add a new URL to be shortened. So for our slug, we're going to put off, because I feel like shortening the office URL. The specific AVD doesn't have the hardware enabled, so we have to use the software keyboard. Now that we've added our slug and our full URL, we'll go ahead and save that URL. We get a toast that says it was created successfully, and now it shows up here, and we can click on it, and we can view the shortened URL. Next, we'll actually look a little bit deeper at some of the code to see what's behind the communication between our Android application and our Windows Azure website backend. To look at our code, let's return to Eclipse. We'll first expand the Shortifier demo package and look at main activity. In main activity, we'll see that in the onCreate method, start URL fetch is called. Let's look at that method now. Here, we're creating a new intent for our URL fetch service. We are specifying a receiver to be sent over to that intent service, and then we're starting that service. Now, if you're not familiar with using intent services, the receiver we're sending over is a member of the main activity class. When the intent service finishes doing whatever processing it needs to do or wants to notify the UI, it uses that receiver to notify it because it's actually running on a background thread. So let's go ahead and expand the services package and look at the URL fetch service. Here you see when onHandle intent is called, we end up calling fetch URLs right here. Fetch URLs is creating a new URL using the constant kgetAllURL, which if we go back to the constants for a second, we see that kgetAllURL just points to API-getAll at our website. Then creates an HTTP URL connection. It opens that connection. It reads the data from the connection into a string builder. It then creates a JSON array and gets a JSON object for all the URLs, iterates through them, adds them to a hash map right here, and then when we're done, it uses that receiver I just mentioned to send a message back to the UI. In addition, it's putting the hash map with all the URLs into the bundle that's sending back to our UI. Let's return to the UI and see what happens then. So, on receive result right here, if it was success, we set an internal property, murlmap, to be what was returned by the bundle, and then we call show our URLs in list view. Let's look at that. Here, we create a tree set from the hash map. The reason we create a tree set is that we actually want to sort the shortened URL slugs alphabetically, and a normal hash map doesn't really allow us to do that. Fortunately, with a tree set, we can get all the keys from our hash map and sort them automatically in the tree set. Then we just create a simple array adapter, set the list adapter to be that adapter, and it redraws itself. And that's what causes us to see our list of shortened URLs like that. Next, let's look at the functionality behind adding a new URL. For adding a new URL, we need to look at the URL details activity. Opening that up, we'll go in here. The view, when you go to a URL and see the details, it's using actually the same activity and the same layout as it does when you go to add a new one. So, in the onCreate method, we're just saying if we're adding a new URL, don't show some of the fields. Then if we're just viewing an existing URL. So when the person taps Save URL, we call this Add URL task and execute it. Add URL task is a distinct task, which is a private class within URL details activity. Here, what we're doing is we're creating a JSON object and putting our data into that, so we have something in JSON format, which is what the server expects. We're creating an HTTP URL connection. We're telling it we're doing both output and input. We're posting content type of application JSON, and we're specifying the content link. We then write our data out to the server, see what the response is, and then read the response back into a string builder. We use that response to create a JSON object and then get the status flag out of that. This then returns whether or not we had a success or not. On the onPostExecute, which is what's called when you return from that do in background method, we're seeing if the status was a success or not. If it was a success, we create a toast, and then we finish the activity and pass back the activity code. If it wasn't a success, we just show a toast. So, provided we do have an success, we're finishing the activity and calling back into main activity. When that happens, another method is called here, and that method is onActivityResult. Let's go ahead and find that. Okay, so if we retrieve back a 1, we're calling startURLFetchService again. So, provided the URL was successfully added, we are again calling to the server and saying, give us a list of all the URLs. This may not be the most efficient way to handle things, in that we know the details of the URL that was added, and really we just need maybe the ID of the URL that was added. If anything, maybe we just need to know it was added, and we can manually add it locally without having to call the server. That's definitely some room for optimization on your own end, but as you can see, here we're just making another request to say, hey server, give me all the URLs. And that's all there is to this simple app connecting to our Windows Azure website backend. There isn't really anything fancy going on here, and if you've done Android development before, you're probably familiar with HTTP URL connection. Nothing's different between connecting with Windows Azure websites and any other backend you might have experience connecting to. So, as you can see, it's relatively easy for you to host your backend in Windows Azure websites and connect to it from an Android application. In the future, I'll have more videos talking about doing a little bit more advanced things with Android applications and Windows Azure as a backend. I hope this has been informative, and I hope you enjoyed listening to it. Thank you.